Hi everyone, I am Hekimian. This presentation is about ECMO and hemostasis, why we need point-of-care viscoelastic testing on our experience with control. Here I'm a conflict of interest. I work in Paris at La Salpêtrière ECMO Center. We receive around 300 VA of BV ECMO per year. One of the major challenges in patients on ECMO is coagulation management. The first risk in this patient is thrombosis, especially of the left ventricle when you have no more ejection like in this patient. You can have any thrombosis of the heart or thrombosis of the aortic roots. When you remove the ECMO, you have also a thrombotic risk, especially inferior vena cava thrombosis, which occurs in 40% of the patients. Sometimes it's a small thrombosis, but in the right side, you can see a huge thrombosis of the inferior vena cava. The rate of stroke is also important, around 5% of patients on VA ECMO. And the second risk in this patient is bleeding. In this series of patients with severe ARDS on ECMO, the rate of massive hemorrhage is 42%. The rate of bleeding complication brain hemorrhage is 3% in these patients. And in this series, about patients on VA ECMO for post-myocardial infarction cardiac shock, the rate of severe bleeding is 40%. And as you can see, 1/3 of the patients had thrombopenia lower than 50 giga per liter. Antithrombotic drugs had to be stopped in 1/3 of the patients. And as you can see, patients receive a lot of blood products. So bleeding is a major issue in patients on ECMO. What is its pathophysiology? In this study, we showed that thrombosis at the ECMO membrane sites with fibrinogen and platelet consumption is responsible for hemorrhagic risk with ECMO-induced consumption coagulopathy, thrombocytopenia and thrombopathy, hypofibrinogenemia, and you had your heparin therapy related to ECMO. So in this patient, you have post-thrombotic risk and hemorrhage risk. The thrombotic risk is related to cardiac stasis, cannula-induced endothelial damage, to ECMO circuit. The hemorrhage risk is related to ECMO-induced coagulopathy with consumption thrombocytopenia and hypofibrinogenemia. With thrombopathy, it is also related to anticoagulation, to the vascular access, and other conditions of the patient, especially liver failure, disseminated vascular coagulation, and antiplatelet therapy. And one of the major problems is that in the same patient, you have often both complications. We have to monitor very closely anticoagulation in this patient, but one of the problems is that we don't have clear recommendation. The main recommendation is that you have to develop a local protocol for anticoagulation. In our center, we target an EPTT ratio between 1.5 and 2, and an anti-10 activity between 1.3 and 0.5 in VA ECMO patients. In VV ECMO, we use preventive anticoagulation and target an EPTT ratio at 1.5. Moreover, anti-10 activity and EPTT ratio are discordant in around 50% of the patients, which had difficulties to manage anticoagulation. So to sum up the difficulties of hemostasis monitoring on ECMO, I will say that there is both thrombotic and hemorrhagic risk. Second difficulties, the time to obtain laboratory results is too long, especially in emergent situations like hemorrhagic shock. Third, classical hemostasis lab tests may not be appropriate in some common situations, especially liver failure, where you have HPTT lengthening but rebalanced hemostasis. Also, in disseminated intravascular coagulation, the last problem is that we do not evaluate routinely platelet function in this patient on ECMO who have severe ECMO-induced thrombopathy and who also receive antiplatelet drugs, for example, after myocardial infarction. So here is what I would need for my patient's monitoring on ECMO. First, I will need accurate and reproducible measurements. I also need easy interpretation. I need to obtain quick results, to have real blood coagulation evaluation. I need the evaluation of both hemorrhagic and thrombotic risk. I need an evaluation of the platelet function and obviously evidence of improvement of patient's management thanks to this monitoring. In my unit, we have for 2 years the Contra system, which is the last generation of viscoelastic testing. It uses ultrasound, it's easy to plug, and it's easy to interpret. It measures the elasticity of the clot thanks to ultrasounds and provides a result in hectopascal with an excellent precision. It measures coagulation activation by intrinsic pathway and intrinsic pathway. This is a dynamic test which explores all the steps of the coagulation. First, the clot time, which is the time between activation and initiation of clot formation. The second time is the clot strength, corresponding to polymerization of fibrin monomers and stabilization. And the last step is fibrinolysis, which is fibrin dissolution. We have the contribution to the plasma proteins, enzyme and fibrinogen, and there is also the contribution of blood cells, platelets, and red blood cells. It can evaluate both hypo and hypercoagulability. So here are the main measurements that we have with Contra: the CT, which is clot time, and CS, which is clot stiffness. So we first have the clot time, which is the time between the activation of the coagulation and the beginning of the coagulation. It is the effect of thrombin generation, like HPTT or ACT. And 7 minutes after the start of clotting, you have the measurement of the elasticity of the clot by shear modulus. And this measurement, 7 minutes after the beginning of the clot, is the clot stiffness, which is an evaluation of the last phase of the coagulation. This clot stiffness is divided in 2 parts: the part related to platelets, which is PCS, and the part related to fibrinogen, which is FCS. For these measurements with Contra, we have 2 cartridges of 4 channels on providing 5 to 6 results. They are fully enclosed, and so it reduces the risk of blood exposure. The storage is at ambient temperature, and the tube is citrate tube. This is the Q+ cartridge, which is used in surgery at high risk of bleeding under heparin therapy, in, for example, cardiac surgery or vascular surgery. And you have 4 channels and 6 results. In the first channel, you have measurement of clot time. In the second, the clot time in the presence of heparinase, so that you can evaluate the effect of the heparin therapy. And you have the ratio of these 2 clot time, CTR, which is CT divided by CTH. You have also evaluation of the clot stiffness which is divided in fibrinogen contribution to clot stiffness that is measured by neutralization of the platelets using antiplatelet drugs. And thanks to clot stiffness onto FCS, you can calculate the platelet contribution to clot stiffness. And the results are really easy to interpret. It's like when you drive your car, you have in your screen the arrow, this is the patient's results, and you have in green the range of normality. So you have the results here for CT, CTH, and CT ratio. And here you have clot stiffness, platelet contribution to clot stiffness, and fibrinogen contribution to clot stiffness. If you want, you can also see the curves, and you can follow the same patient, the evolution in the same patient. So this is 3 simple steps. The first is to insert the cartridge. The second is to cut the tube. And the second is to start the test and to obtain the results in 15 minutes. We now have data about contra in the literature. In this first study in patients on receiving cardiac surgery, it was shown that there is good correlation with lab hemostasis. First, good correlation between fibrinogen and FCS, and second, good correlation between platelet counts and PCS. In the same study, they found the threshold values corresponding to a fibrinogen level of 1.5, which is FCS at 1.3 hectopascal, and also the threshold value corresponding to a platelet count of 50,000, which is a PCS at 11.2 hectopascal. In this other study, also in cardiac surgery, they compared contra parameters to classical lab test parameters and to tech parameters, and the correlation is also good. In the study in trauma patients, the authors describe the correlation between the work time and the control parameters, and as you can see, this correlation is also excellent. And in this study, again, in patients in cardiac surgery, there is a very good correlation between the control parameters and the tech parameters. Last study, we showed in COVID-19 patients that control allowed us to evaluate the hypercoagulability of these patients thanks to clot stiffness, which is really higher than in non-COVID-19 ARDS patients. So, to conclude, here is the sum up of what Contra can provide to us. The first, there is very good correlation with lab test, TEG on rotem. Second, it's very easy to interpret. We obtain the results in less than 15 minutes. It's a real blood coagulation evaluation. It provides an evaluation of both hemorrhagic and thrombotic risk. There is an evaluation of the platelet function thanks to Contra, but it has to be evaluated. And for the moment, we don't have evidence of improvement of the patient's management, and that is why further studies are required. Thank you for your attention, and I hope you will come to the workshop this afternoon.